Hey guys, welcome back to Ox Tools. I'm Tom. So this is Meatloaf episode 97. So I was thinking about that the other day, and that's a lot of meatloaf. So I'm thinking about that 100th episode. So if you guys got some ideas there, throw it up in the comments. I'm trying experimenting. You guys may have noticed this last video that came out, Money for Nothing. Doing a little experimenting there and having some fun. So anyway, if you have any ideas for an epic Meatloaf 100, throw it in the comments. I'll take a look at it and we'll see what happens. So we've got some eBay purchases, some kind of interesting stuff. It relates to some of the other things that we're doing around here. No viewer mail this week, but you know, that's the way it is sometimes, and you know, I always appreciate it when guys, you guys, send stuff into the show. It's fun for me, it's fun for you, so I really appreciate it. So let's pop over to the table over here, and we'll look at some eBay purchases, and I think you'll get a kick out of them. And then we got a little bit of we're going to do a comparison for one of our friends in Europe, and he asked to do a little test on something, so we're going to do that for him. So let's go check it out. Okay, so these first two are these crispy little boxes here, and these are the boxes have seen better days. This looked like it was in another cardboard box and it got wet maybe. What we have here, and these are kind of cool, are these Dillon Dynamometers, okay? And there's two flavors here. This is a 1,000 pound, and then this one here is a 500 pound. So let's take them out here and we'll just kind of get a look at them. We'll, set these aside here. Okay, let's make sure those are in the frame. Okay, so the way these work here, they have a threaded connection on either side, and this whole yoke here is basically a giant flexure. Okay, actually I can probably squeeze this one a little bit better here, and you know it kind of limits its travel before it yields there. But see, I'm squeezing that, and they're meant to be squeezed about the center line here, and that's what they're calibrated for. I got a great deal on these. Some guy had these, and I don't know, just wanted to get rid of them. 20 bucks a piece plus shipping. And this is kind of a similar thing to the Dynamometer, which you've seen, okay? But these are pure compression ones, and this is you don't want to move this thing here. They calibrate this, basically. They check it in a bunch of places along the scale, and they adjust this angle here so that to compensate or to match the spring rate of this particular material, or excuse me, of this shape. So anyway, we'll do a demo on. Let's do a demo on the big one here, because I got these big studs here. We can put it in here. So I'll show you something you can use something like this for. And I've often thought about it. What we're going to do is we're going to take it over and put it in the Kurt vise and give it a little nudge and see what happens. And also, it's kind of some feedback. It's a little bit of feedback. So as you're tightening the vise, you know, you got a little bit of feedback as to what that actual force is, okay? Which is something I've always thought would be kind of cool, is to just build something like this into a Kurt vise, right? That way you're not relying on torque through the screw and all that friction and all that stuff. You're just directly measuring that clamping force. It would be very handy for certain kinds of operations where you want a very, very consistent clamping force. So let's pop over to the mill and let's take a look at this over in the Kurt vise. All right, so let's slip that in there. set that up. We'll put it in the center there. And we can set the telltale there. Like that. All right. So, you know what? That's actually distracting. Let's crank that around. 100 pounds. It's 200 pounds. 300, 400, 500 pounds. So, you know, I'm using this, my kind of ball handle here, right? And I released it. Yeah, 500 pounds is probably one that I use pretty regularly, okay? Just feeling it on the handle here. Let's go a little farther, 700. Yeah, 700 would be what I would consider pretty snug here in the vise. And 800, 900. 900 would be a stiff clamping with this particular handle here. So now, you know, obviously with the longer handle, you can go nuts and bury this gauge. But you see, it's all, you know, we're in the elastic range of this material, right? So the force is relatively linear, okay? You know, we're not yielding this. And this has a, you know, I'm pretty sure that this is an over travel gap here so that you don't, so that you can't, well, it would be tougher to yield that and destroy that. But can you imagine one of those built into the Kurt vise itself, right? So it's monitoring the pressure of the moving job, which would be pretty neat. Let's flip this over, and you can see the back here, and it's just a you know, it's just an indicator that they've calibrated. You know, they've had their own little dial faces made, you know, with their name on it and etc. But so this is how you move the indicator in and out to kind of set zero wherever you want. And the important part is this little monkey right here. Okay, that angle, and you see what they do is they put a little witness paint on there so that they, you know not to move it, or you know, if you send it back and it's got a problem, they see that's been moved, then they go, okay. So this is mounted to one side of the flexure, and it's suspended in there. But it's a very simple thing. Any one of you guys out there could make this, okay? You know, you could make this on a bandsaw, literally, okay? And you know, I've seen these, you know, 50,000 pound capacity. So, you can make them basically in any kind of load range that you care to make. So, okay. Anyway, so the Dillon compression gauge, pretty neat. So we're going to use these to do some more tool testing and kind of general testing around the shop. All right, so you know, I showed this Vblock, I don't know, a week or so ago. This was an eBay find here. Well, I got another one, and this is the new one here. And this one's kind of weird and it's special. Let's set that one aside. That one's boring now. This one it's a commercially made one. It's made by Atco. It's got a name on it somewhere here. Yeah, right there, Atco. But if you notice, the V angle is kind of trippy. In fact, it's a 60-degree included angle, which you do not see very often. And this actually has a special use. Let's see, do I have something around? Yeah, I do have something around over there. This is used to inspect round parts, okay? And when you do centerless grinding, depending on your setup and your wheel diameter and your work diameter and, you know, a bunch of other factors, you can get out of round conditions, okay? So you can, let's see, let's get something round over here. So you can do a 2-point measurement, okay? You can do 2-point measurement, that's 1, 2, right? You know, across, and it measures correct all the way around, but it's not round, okay? So this is a very difficult thing to inspect for, because normally a lot of our instruments are are 2-point measuring, okay? So the real only way to inspect roundness is with a stylus and an accurate spindle going around it, okay? So 2-point measurements do not show roundness, okay? So a lot of people think they do, but they don't. Okay, so when you get into real fussy stuff, you need special equipment to measure roundness, okay? And CMMs, all they're doing is they're just extrapolating a zillion points, okay? So they do curve fitting and least squares fits and things like that to approximate circles. So what they're inspecting is, you know, polygons with zillions of points, or maybe not zillions of points. I call them, you know, many-a-cons, okay? Anyway, so in this particular situation, if you roll something round in a 90-degree V-block and you put an indicator on it here like this, okay, you may get a very nice reading, okay? But if you then put it in a 60-degree included angle V-block, it's a completely different story. So the contact pattern, or you know, between the indicator and the sides here exposes different numbers of lobes, okay? And there's a very interesting picture floating around on the web made by the Van Kuren company, and they prepared a bunch of cylindrical shapes that all have the exact same diametral 2-point measurement, but they're just obviously not round. It's very trippy to look at. Anyway, this particular block, and you know, honestly, I've never seen one in the flesh before. It was popped up on eBay, and it was, you know, it was $40 or $49 or something like that, and a little bit of shipping. You know, it's a little spotty, but I'm sure it'll clean up really nicely. This looks like a, actually this is a challenging grinding job down here since you don't have access, so you have to have the wheel dressed off at an angle, right, and to reach down in there and do that work. So it's kind of a challenging grinding job. So anyway, so that's kind of an interesting piece. Don't see that very often, and I don't know, just needed to go into my V-block collection. You know, I've been collecting these blocks so I can refinish them and you know, play around with the surface grinders. So some of these are surface grinding projects. So okay, pretty cool, huh? All right, so this next one, this is kind of an interesting bit here. What these are, you know, some of the eBay hunters out there may have seen this stuff before. These are gauge block accessories here, but they're kind of special ones, and I'll kind of explain what these are used for here. This is actually was just a bonus thing. So those are all the same. Those are the same. Those are all the same, and those are all the same. So this is all the different things here. So what these are they're made by Pratt Whitney, and they're called Hoke, H-O-K-E, gauge block accessories. And a guy on eBay had a little lot of the stuff, and anyway, they were cheap. They came out of somebody's toolbox that had squirreled them away or whatever, and actually that one looks better. So I'll kind of show you. This is so you can use gauge blocks to make functional fixed gauges if you have a bunch of work to inspect, okay? And there's different flavors, so you can check bores, inside diameters of different sizes. You can check, actually this is a good one here. This is I'm not quite clear what you would inspect with this. It's they're exact 60-degree points that are 100,000ths off of this surface here. So you might inspect 2 points on something, or 2 hole centers or something like that. Although it's not super definitive for hole centers, so I have to look that up and see how those. Maybe one of the viewers out there has a Pratt Whitney Gage book. I don't happen to have one, and it shows these being used. So maybe somebody can chime in there. I'm not sure how you get a super hyper accurate measurement with that. So but I'm sure somebody does. Okay, and then this is this subscriber here. So what I'll do is I'll clear the decks here. I have a small set of Hoke blocks here, okay, with the tie rods and all the stuff, and so we'll put together a little gauge, and you can kind of get the idea of how these might be used. Okay, so we've got a couple of these the radius bits here, and these are 250 radius here. So if you put those together, it makes a 1/2 inch diameter exactly. So you might use this for in a situation. So this is a 4-inch block here, okay, and Hoke made all the increments, so you can create any possible increment to very, very close limits with these gauge block accessories, right? So if we tie all this mess together here, we're going to end up with a very precise 4.5 inch gauge, right? But we can easily make that 4.515 or something like that, right? So that you can have a high limit and a low limit, so you can make a go, no-go gauge, a custom one, basically, for inspecting a process or parts. So you can make fixed gauges out of these pretty quickly. So let's just go through it. So they have these tie rods, and these are kind of the sectional ones here, so you can extend them like that and make long. Let's see, what do we need here? What do we need for this little guy here? Actually, about as short as it can go there. And then we put a little flathead screw in it. Let's put that in like that. And then it slides down through the middle. So the square gauge blocks typically have a hole through the center. Let's see here. You know what? I might need to go a little longer here. I don't have a shorter rod. The bigger sets have rods that shorter rods, so you can make actually itty bitty little ones here. So let's maybe we'll use. Are these thicker? Oh yeah, let's use these. So these are a little different. This would be for an ID measurement here. So let's do that instead, so I don't have to waste a bunch of camera time there. Okay. Oh yeah, that looks better. So now let's thread that in there. Get it started. Okay, so this is the general idea here. All right. So what we've created here is we've created a very precise a very precise 4-inch space inside here, okay? So these are our measuring surfaces here. These are lapped flat, and so we've created 4 inches. I don't have a calipers handy, so you'll just have to trust me that that's accurate as good as the gauge blocks are, right? And so we can create, so now we've created a 4-inch gauge that we can actually go on and check parts. Or it could be 4 inches and 2/10 if we wanted to, by stacking up the appropriate gauge blocks. Now my little Hoke set here isn't big enough, and I'm hoping to add to that and increase it so that I can do this kind of a thing. But this was just something that kind of goes with the gauge block accessories and all that. And as I get more of this stuff, I'll show you. But this is just one little lot that I bought off eBay to go with my Hoke blocks. So I kind of like the square ones myself as opposed to the rectangular ones, but I have both. So anyway, Pratt & Whitney Hoke Gauge Block Accessories, pretty cool. All right, so this next one is kind of interesting. It's a little demagnetizer. It's a little cutie here. Now that I'm you know, doing some surface grinding. I got the surface grinder and the permanent magnet chuck. You know, things get magnetized. And, you know, I've been wanting one of these for a while. I got a couple of tools that are just annoyingly magnetized. You know, it's not enough to really stop what you're doing, but, you know, it picks up chips and it's just kind of a pain in the, you know what. So, you know, it's plugged in right now. It doesn't make any noise until you put something across it. Let's do something. Yeah, I've been running around the shop demagnetizing everything, so I had to find something that was magnetized, and this file is actually pretty well magnetized, and I'll grab some chips here in a sec. And files in particular, when they're magnetized, or you know, you're filing steel, well, guess what happens? You know, it starts looking furry, right? So let's stick some in there, okay? And you can see that, you know, okay, it's magnetized, right? All right, so let's do this. Let's put those down, and we'll run this through here. So I think it's just going to be like. All right, let's see if that did it there. Yep. Okay. So that's it. This was 35 bucks on eBay, plus a couple bucks to ship it. This is made by Mite. I wonder if it's the same guys that make those little, I don't know. These guys might be into this shape here. I don't know if it's the same folks. There's also another magnetic company, Mite. I don't have one here, but it's a little indicator magnet. Sort of looks like this, and it's got a rod coming up, and it's called a Mite. I think it's called a Mite, actually. So, do I have one of those around here? I don't think I have one of those around. Anyway, so a little demagnetizer, a little Simple Simon one. You know, there's bigger ones if you have bigger plates to work on. This one's kind of nice because it's small and you can just take it around with you. So and do little parts. Okay, eBay find. All right, Kjeld. This one's just for you. This is for my friend Kjeld Sorensen in Daneland or Denmark. Kjeld built one of these based on his observations of me just disassembling this one here, and so he did a little test where he tested the holding power of this spherical joint here, and did a little test in his shop after he made his. So he asked if I would go ahead and test this one, and it's like, sure, why not? Make some good video. So this is the Wilton Power Arm Jr. Okay, and this is the factory-made one here, and we're gonna try it out. Now I don't have any individual weights to hang on it, but what I do have is I have this dynamometer, and yes, this is a dynamometer. Dynamometers are not just for cars, so there's some folks out there that have a different idea what a dynamometer is. So this is a dynamometer. It's just a little one, okay? It's for measuring forces, okay? And in this case, this one is in pounds, and this does compression or tension, and we're going to use this one in tension here. This one goes 0 to 30 pounds, okay? And so let's get this thing set up here. I got to clamp it to the bench and kind of rig it up, so I'll change the camera around and you guys can watch me do that. All right, so I think we're going to put this on the bench here. We'll put it over here, so that way we can get 2 clamps on it. All right, so one there, put it in the corner. Clamp her down. Simulating our bolts here, okay? That should be enough to hold that, okay? And there you can kind of see this thing articulates around pretty nicely there. Okay, so what want to put an arm on here. That way I can apply a torque to this joint here. I think what I'm going to do is I'll get another piece and we'll clamp that in between. I think is what I was going to drill some holes in that, but then I think we can just slip it under the head of the bolt and it'll be strong enough. So let me snag a piece. Piece there. These silly washers in here right now. Do that. So, yeah, I think that'll work. Squeeze it up, oops, there. Squeeze it up against the fasteners there, and then snug that down. Okay, so then I think we want to be, our reference mark on this end is just going to be the center of rotation. I can't remember how Kel did his, but we're not quite 12 inches. We're not quite 300 millimeters. So, okay, I think I can scooch that out a little bit. Let me go for the max here. All right, stay. Stay, bad dog. All right. Boy, that Allen wrench fits tight there. Oh yeah, so we're good. So we're right at the end here. So we can get 12 inches right out at the end. And then I think we're going to just put a little clamp on the end here. Right out at the end. Make sure that that's 12 inches. Yeah, that's pretty good. Yep. Okay. More. Go to there, crank that down. All right, so there's our setup. What's next here? I think I'm going to move the camera and I'll bring you in on top of this thing here. All right, so I'll put that on there. Oh, hey, I got it pretty close right out of the gate. So I'm going to set this level to start with. And this will be our kind of quality control check there to see if, you know, it'll change when I pull on it a little bit, but you know, if it shifts, then we'll get it'll be out of level. Hello, yeah. All right, I'm going to set a second camera up here so that we can watch the force gauge and this at the same time, and let's do some testing. Okay, I think we're ready here. Let's make sure that's on 0. All right, we're level. Okay. I'm just going to hook onto the screw here. Okay, I think this camera can see what I'm doing here. Make sure I'm kind of holding it so we can watch it. So I'm just going to pull on this manually here. And let's see what happens here. I forgot to check and see if it was locked. I think it is locked. 12 pounds. 14. 15. Ooh. So it looks like it cut loose at about 15 foot-pounds. Okay. Let's do that again. Let's double check. I re-level it. So we're kind of starting at the same spot. Okay, it's fully locked. All right, let's do that again. So we get some statistically meaningful data here. Okay, here we go. Steady Freddy. 13, 14, 15, 16, 17, 18, 19, 20. I guess it wasn't locked before. 21, 22, 23, 24. Jesus. Oh, there it goes. Whew. Boy, that was kind of hard to do, kind of smoothly and steadily, right, without jerking it. So I think it was 23 or 24 pounds. All right, one more time. We'll reset everything here. All right, here we go. Oop. Hey, dopey, we gotta reset that. All right. I'll try to watch the gauge myself now. All right, here we go. 15, 16, 17, 18, 19, 20, 20, okay, 21 that time. So it looks like it might be a little bit variable, which wouldn't surprise me, you know, because there's going to be different roughnesses in different areas, you know, surface finish and whatnot on the ball here. So it wouldn't surprise me if there's more favorable spots. So, but we got two readings that were over 20. So I would say that that's probably a reasonably safe number, that it's about 20 foot-pounds on that joint. Then it starts to get slickery dickory dock. Anyway, Keld, there's a desk for you, the original Wilton Power Arm Jr.